It is my pleasure to introduce Tilbe Göksun to you as a keynote speaker for today morning. Tilbe is professor of psychology at Koç University in Istanbul. She's also the director of Language and Cognition Lab. In 2010, she received a PhD in developmental psychology at Temple University in Philadelphia, USA, working also with Kathy Hirsch-Pasek. She received numerous honors and awards, and very impressively, she also gained a lot of research grants. So I don't list them all here, but would like to point you to the interest. So what is Tilbe interested in? She's studying language, gesture, and thoughts in interactions at different age groups and populations. So this is linking very nicely to Masatako's talk from yesterday evening. She's also doing it from a developmental perspective and also in a very interdisciplinary manner. So this is why we are very happy that you will present today. So please welcome for Tilbe.
Okay, working now. Yeah, I can hear my voice. All right, good morning, everyone. Thank you so much for being here at an early time. And thank you again for the whole committee and especially Katerina inviting me to talk, to give my lab's work in here. I will mention a little bit of robots here and there, but mainly I'm going to focus on our developmental work that we have been doing for almost like 20 years at this point. So some of the work are really coming from my ideas and thoughts from the PhD program. And then when I moved back to Turkey, I started continuing on the link between basically different cognitive processes and language. But today I'm going to focus on specifically spatial cognition because I thought that it's also an interesting topic for this group. And when we talk about spatial cognition, many of you would know that it actually encompasses different things. So one part is definitely what we call intrinsic or inter-object relations. And it's basically how you transform objects in your mind is particularly part of it. So such as, thinking about a 3D version of an object or mentally rotating it in your mind. But spatial cognition also involves more inter-object relations, mainly when we think about our navigational skills, how you walk to the metro station from here, or something is just like moving down and trying to find the poster session in your first day. These can be part of our inter-objects and how we navigate basically in space type of spatial cognitive processes. But I'm going to focus on the first part, not the navigation part, more like how we think about objects, how we talk about objects, and how we basically learn to mentally rotate them in our mind. So you may ask why this is important. As most of you know, coming from particularly engineering backgrounds, those of you know that this is an important skill in life in general, but also a very important skill for some of the STEM disciplines, basically. But I think we all need to have those skills. It doesn't matter whether we do work in engineering or not, but particularly in those, it becomes actually even more important. So our key question is, how does language relate to all these processes? You may say why language would have anything to do with it. Because when we actually think about all these spatial relations, we started talking about them. And when someone asks you how you think about how you rotate an object, how you solve this problem, you use language. So particularly in early childhood, language and spatial cognition seems to be interacting a lot. But I want to highlight one more thing before I move on to showing you some empirical findings of how these relations could be interactively related to each other, how these two concepts. Language is not just what we talk. So language is multimodal. So what I mean by language is when two people are talking, as you know that they are following their eye gaze, they basically even look into their postures and how they think about things, you know, where I'm actually looking, but particularly they use a lot of hand gestures. So hand gestures, I'm sure some of you also do research in these topics. Hand gestures are particularly important, not only communication, but also in thinking. So that's why, for example, when you ask even adult participants, how do you rotate these mental objects? So those who basically use their hands while thinking about rotating those objects do them really better than the others who don't actually use their hands. So there seems to be a connection between gestures and spatial cognition because gestures are also spatial. Sometimes when we talk, you know, the spoken information captures a categorical type of information. So when I say above, it's a categorical way of saying above, but while I'm making the gesture, you know how above is. You know, you can see the difference basically because gestures capture the spatial information in certain cases much better than the spoken information. And this is even true, you know, when you talk on the phone. So try to, for example, describe any of the tasks that I just showed you on the phone to someone else. Basically, you start using your hands even no one sees you. So that kind of highlights the importance of gestures in our thinking processes because we do not necessarily only use them for communication, but we also use them for ourselves to basically reason about specific relations. And I mentioned that it particularly becomes really important when we actually think about spatial relations. Okay, so after this brief introduction of space, spatial cognition, and multimodal language, I want to just put different hypotheses how they might be related. So first, let's say these are two big topics that I'm going to talk today. One of them is basically spatial cognition, and I will selectively use the part of mental rotation, spatial reasoning. And the other part is multimodal language, in which I will use both speech and gestures as part of it. And I'm going to focus on, even though my lab does research from 0 to 80, basically we are testing children and at different ages, adults at different ages, and even neuropsychological cases. Today, I will focus more on our developmental work on this topic, and if I have time, I will briefly kind of show corroborating evidence from the adult work. So here are the hypotheses and the possible things that spatial cognition relates to language. One thing is, we may say spatial concepts are necessary to talk about these spatial multimodal language in that way. So when we look into, for example, very young children, we may see these topics that whether they actually have, I'm not necessarily saying that these are inborn concepts, but I'm saying that they may need these concepts to basically talk about them. But of course, there are other views, particularly in language development research and early research, that we need language to think about these concepts. So this kind of means that, particularly in certain age groups, when children start learning the language, spatial language may be necessary for thinking spatially, basically. So I will also show this part of the evidence. But the third part is, we usually, in every single area, right, we like the sort of in-the-middle approach and how these two things might be related. We may also say that they need each other at different time points, not necessarily just in childhood. For example, when you try to think about a specific spatial task, thinking in multimodally, even in our age, would be helpful, as I just gave you an example. Or the other way around is also true. These things are basically so much intermixed that it's difficult to find the unidirectional link between them. So my goal here is to show you some type of empirical evidence on different links that might be related to spatial cognition and language interaction. Okay, so if we start with the first hypothesis that spatial concepts are necessary for language, we can actually go to really young infants and who do not necessarily say much about that, who may not have much multimodal language part. For example, very young infants, even 6-7 months old, so this is not my research, but accumulating evidence shows that they can differentiate different spatial relations before even talking about them. So one of the best examples many years ago came from a distinction that happens in Korean language, but not in English. For example, in Korean, when you talk about some of the spatial relations between objects, you need to not only focus on certain things like in and on, but you also talk about the tightness versus looseness of these interaction, between two objects. So, of course, from an English learning child perspective, this doesn't mean anything because regardless of the tightness or looseness of the interaction, they kind of put a bigger category of in or on. However, the research suggests that even before learning language, they pay attention with looking time experiments. They pay attention to these distinctions. So it looks like that before learning their native language, children might be what I keep calling language generalists, meaning that they are actually open to different types of directions between objects, interactions between objects or relations between them. But when they start learning language, they become language-specific users and focus on specific relations between objects. So this is usually called as concept-to-language view, and as I mentioned that this view suggests that children need the spatial concepts before they basically talk about them. So of course, this is kind of my view, and not everyone agrees with this view. Some people really think that the children need the language to bring up those spatial concepts. But I'm going to also say that this is not the same particularly for every child. So the more I study in this area, the more I kind of started learning that children learning the same language basically follow different pathways too. So I just mentioned, for example, an American child or English learning child and a Korean learning child, they may differ after the first year of life because they start getting different types of input. But the research suggests that it doesn't matter, whether you learn the same language, because there are huge individual variations among children. Children also follow different pathways. So these differences in children while they are learning the language come from their attentional patterns, how they form the concepts. For example, some children are better at making these distinctions than others, or we know statistical learning is very important. Or children's other cognitive motor skills, their genetic predisposition, all of them are really important differences. But other differences come more from the environment, such as the parent-related factors. And here I'm going to only focus on the parental input, so what type of input they hear in their environment. I will also show you a few things that, since this is an important topic and research keeps showing the importance of spatial cognition in STEM disciplines, we have to sort of intervene to this process. So whether we can change if children coming from an individual disadvantage or something related to this, or maybe they are not aware of these spatial cognitive processes as well as some other children. So I will also show you a little bit of how we may intervene, including some of our robot studies. Okay, so I'm going to start with the first question that given that children form early spatial concepts for object relations, why do some of them learn words earlier than others? Because if the bigger assumption is correct that they should follow similar ways, right? And in my earlier research, I made these bold arguments, obviously, when I was a PhD student. It looks like these are universal, learning this, but it looks like it's not that way. So, for example, the input that I'm seeing seems to be the key for children's learning of these spatial concepts. So I kind of mentioned what type of spatial language people use, but not only the prepositions, obviously, some of the verbs are very spatial too, like pushing, up and down, going up, going down, or other verbs, motion verbs. But at the same time, looking into like big, the features, spatial features of the objects are also part of the spatial talk that parents may use. So in an earlier longitudinal study, we wanted to see, how much parents basically to very young children talk about spatially, because spatial concepts seem to come a little bit later. So before this research, many people started looking into spatial input at around 3-4 years of age. But we wanted to see an earlier aspect of it, to see whether at 16 to 21 months, for example, how much spatial talk and gestures are given to children. But we also wanted to see that because we have data from an earlier time point of how much children actually know about these spatial words, basically related to their vocabulary knowledge. And the next question is, we ask whether the spatial input basically changes based on the child's knowledge of the spatial concepts. So here is a session, basically a play session, but in the specific part, we basically gave the parent-child a puzzle. It's an interactive puzzle session, so they are making the puzzles together. So I muted it because it's in Turkish, maybe only a few people would understand in the group. But basically, the parent says, turn, turn, put it in here. But as you can see that, more importantly, the parent makes a lot of gestures. So what we did was we coded the spatial speech, but at the same time the gestures that the parents use. So what we showed very briefly is that basically parents use a lot of spoken and gestural information, but more importantly, in particular, their use of spatial verbal language changes based on what they think their child knows. This is not true for the gestures, so they gesture regardless of the child's knowledge. Only the verbal input change. So we argued that yesterday in one of the earlier talks, there was a tailoring argument. We also argued that specific input might change, parents might tailor their input based on their children's knowledge because the data came from an earlier time point. So in a follow-up study to this same longitudinal study, we basically had the same children here, but we also had their fine motor skill data. We didn't use it in the first part. But we also picked up specific type of, even more specific spatial input as referring to the object features. And we followed them up at 2 years of age and looked into their spatial object word comprehension. So how much they know about the object words, basically. And what we show is that even their skills, fine motor skills, are important, but when we enter spatial input to the picture, basically, it becomes even more important than children's own motor skills. So what we kind of concluded is that both the fine motor skills and using different words for spatial features may foster infants' visual experiences in play environment, and they also explore even more and more in that, leading to better object word learning. So not only spatial input, not only children's attentional or patterns or motor skills, but together they basically make these episodes possible. However, this was an argument. We did not necessarily test in this longitudinal study specific object exploration of the children. But in a follow-up longitudinal study, we asked this specific question. Basically, this time, let me show you the video. At 14 months of age, again, this is a different play session. The child and the parent were playing as if they, do at home. That's how our instruction was. We didn't give any specific instructions. But as you can see that this child, of course, I picked up the child who does a lot of object exploration. This child makes a lot of object exploration and showing it to the parent, and the parent says something that's important for us, the spatial input. So we looked into, at 4 months, the input from the parent, child's object exploration, And then at 26 months, we tested children's spatial language comprehension. This is not production, but mostly comprehension. And we basically wanted to see whether these two things are related. So I'm not going into all the details of the study, but what I want to show you is that basically, as you can see from this graph, object exploration and the input interactively relate to children's later spatial language knowledge. So the more they explore, obviously, the more they hear. These are important, but we also tested the co-occurrences of them in a detailed analysis, and it seems that half of the spatial input comes at the object exploration episode. So this is an important finding for us. And by the way, I know I saw some posters related to preterm and term, full-term children. So we had both types of groups in this study, and I want to say that regardless of the children's neonatal status, this is basically relevant for all children. So the more they hear the spatial input and the more they explore the objects, regardless of how they were born, basically, they were positively affected by these type of input. Okay. So I started with spatial cognition. There are concepts, and language basically maps onto these concepts. But I wanted to show you the importance of the parental input in this case, because even though they have the concepts, they need the push from the parents, basically, to really make this spatial reasoning better. And the child-related factors are very much important in how much parents basically talk. In particular, in our cases, more talking about them, because we didn't find the difference in the gesture use. But the second part of my hypothesis was that children may also need the spatial language to think spatially. So in this case, I'm going to look into a little bit older children, because spatial input comes to these young children. It's very nice, but when we look into a little bit preschoolers, we need the spatial language happening, because it looks like that before the ages of 3 and 4, children don't necessarily use a lot of spatial words. So in this case, I'm looking into preschoolers and ask the question of how do children's spatial language knowledge associate with their spatial reasoning. Okay. Here is our famous mental rotation task. So in 3 different studies, I'm going to talk about the mental rotation task, very similar to this one. And this is a child-friendly version of it that was tested and conducted by Susan Levine's group in the University of Chicago. So basically, this is a simple version. The child needs to really see, which one of these objects basically make, when you put them together, which one makes this up? So it's a simple question to the child. But we also created a language task because we wanted to understand their language. So here I use postposition because in Turkish it's not pre, but post position. But don't worry about that. It's like the prepositions. So we basically made a task that we try to understand children's spatial vocabulary knowledge. It's both at the comprehension and production level, left, right, above, under, and all these ones. But we also wanted to give them a bigger relational reasoning task, try to see whether these things are directly related, or maybe there is a bigger component that relational reasoning seems to be also important to mental rotation and spatial skills. And in this task, basically, it's simple. The child needs to find the same relation with the top figure. So which one seems similar to the top one? So that's the question to the child. And we basically ask whether children's spatial reasoning change based on their knowledge in these, or performances in these 2 tasks. So first of all, I want to say that we have intentionally a huge range here because we also wanted to take the age into account. And between 3 and 4 years of age, basically, their performance in mental rotation increases. When we look into their spatial vocabulary knowledge, some of them are nice, but left, right, it's very difficult for young children. So as you can see that their spatial language varies a lot too. So this is good for us to see the relationship between these 2 things. When we look into what happens, which are the best predictors basically to their mental rotation performance, we see that both relational reasoning and children's spatial language knowledge, when we enter comprehension and production separately, we get the same results, but it's a composite score. And basically they are both important. So it seems that children who know and produce more spatial language are better with the spatial reasoning task at this age. And it seems that it is beyond the regular increase of the age because we also get an interaction of the age and postposition knowledge. So it's beyond the age, main effect of age basically on this relationship. Okay, so this was nice, but as I kind of started in the beginning, I say that language is multimodal. So what about gestures, right? I mean, do children who gesture more are better with these types of tasks because gestures might be helpful to children's spatial reasoning skills? So in a recent study, we basically tested a little bit of a different mental rotation task. Here, we got the simple versions like just the translation ones, but also these are, as you can see, that pretty difficult tasks for children because they really need to mental rotate them. But in this one, in addition to the accuracy, we also added something that is kind of new in the literature. We also wanted to see, whether children's gestures also influence their confidence levels. So what do I mean is that they get a trial. We ask one group of children to solve the trial by using their hands. We basically tell them that, oh, use your hands while trying to solve the problem. In the other group, we didn't say anything to half of the other children. But when they solve the problem, we also say how confident you are in your response. So with children, of course, we make it as fun like this, and they pick up one of these, obviously, from that. And these are, again, preschoolers, 48 to 72 months. So in general, children in the gesture group performed better. So gesture seems to increase their accuracy, but particularly in the more difficult trials. So if the trial is easy, we don't get the group difference necessarily, but in the more difficult trials, we get that. But very interestingly, and this is actually the first time I'm talking about these results here in front of the community because this is a new research, we also find the change in the confidence. So what we showed is that gestures, children in the gesture group, not only they are accurate, but it also increases their confidence. So just making these hands basically feel them more confident. I have to mention they are overconfident overall compared to adults, but still we get this significant difference in that, and I'm happy to talk about that even more. Okay. So the last part in here is I want to connect at this time the spatial input and children's own knowledge. So how do we combine these multimodal inputs? So here is our mental rotation task. And this time we asked preschool parent and children to basically solve a puzzle together. So in my first case, because children didn't gesture or talk spatially much, we couldn't necessarily understand the children's side. But here we coded both the parents' verbal gestural information spatially and the children's verbal gestural information, try to see how they interact and how they interactively relate to children's mental rotation skills. Again, these are for 5-year-olds. The other children were Turkish learning, but this is an English learning group. Okay, so this is basically our significant result. I didn't put a lot of numbers in here. Parents' use of words relate to children's mental rotation skills, and their gestures also relate to children's mental rotation skills. But more importantly, when we basically put children's knowledge of the words and gestures into the picture, the direct links disappear. So this seems to be a mediative role. So parental spatial input is mediated by children's use of words or gestures. So it looks like, let me just say it in one other way. Parents can talk as much as they want, but if children don't talk spatially or don't gesture spatially, it doesn't necessarily help them for their spatial reasoning. So children's spatial skills, spatial language, multimodal spatial language seems to be necessary for their mental rotation skills. All right, so here is, as I mentioned, language knowledge links to spatial reasoning. Children's gesture use also increase not only their accuracy, but spatial reasoning and confidence. So it seems that there's something going on with these multimodal language use. Parental input, particularly for preschoolers, when children become older, when they start knowing more about this vocabulary, they may become prominent through children's spatial language use. Okay, so the last part I want to really say, can we intervene in this process? The reason is, as I'm saying, spatial language and spatial cognition, they both seem to be key for success in STEM disciplines, particularly younger age groups, and particularly in certain countries, I have to say, over others. And there's some work, obviously, including us, that we want to see, you know, what really makes spatial reasoning to the surface, but what brings it to the surface for children. And we know that even there were some, again, talks, posters yesterday about the blocks and other things. So these are very important, puzzle playing and stuff. And in some of our earlier work, my interdisciplinary work with design students, we actually created different designs and pushed children and their parents to talk more spatially. And in there, we actually showed that children's use of different rotations, for example, when they are working with the tangrams, are really important for their spatial skills and spatial reasoning. So these things become more and more important, but I want to say one thing to this group particularly about a study we did with robots. So in this case, I want to mention whether we can basically use robots to teach children some of these spatial words that they don't know. That's why we picked up second language with preschoolers and tested robots. Of course, to this group, I don't need to say really why robots are important, but I want to say a few things about, particularly in education, they may be important. So there is a part that, particularly the second part, is we can make the robots adaptive, and it's also very motivational for young children, particularly for preschool-age children. So we want to see, I mean, even the novelty may be good for children. We wanted to see whether we can teach children in the spatial words in their second language by using robots. So here is a design. Let me go through the design. So here is either we teach the same words either with a robot tutor or a human one. I'm going to show you a video. But there's also an image on the screen, and in some cases, we don't necessarily highlight the image, but in some cases, the image is basically highlighted and created an attentional cue. So in these ones, basically, so we have robot to human, and there's an image on the screen, but there's also other conditions that the robot sometimes uses just a didactic gesture, pointing, or making an iconic gesture, making big, let's say, and same with the human tutor, obviously, or does nothing, and only on the screen it's just flashing, okay? So it's a complicated design, but I think it will be clear when I show you the video. We basically teach different spatial features to 5-year-old Turkish learning children in English. So here is a video, let's watch it.
Big O, big, big. Big.
Okay, so from this video, I got really excited when the data came in because the robot gestures, the child gestures, I'm like, we are winning, you know, so it's great that the child actually repeats the word. Unfortunately, not that much. Okay, here is the result. Yeah, that was a failure. Yeah, so you pick up individual differences, right? Okay, so here is the result. Even though in the robot condition overall, basically, as you can see that, children are a little bit better. But it looks like, so let's start with this way. Children learn L2 words from the robots, which is wonderful because they didn't know anything and the robots are interesting and engaging for them, and they learn even better compared to human condition. But this is an overall effect. So unfortunately, the gestures are not necessarily helpful that much. So as you can see that the red one is the screen cue where there's a flashing. So they learn, better when there's a screen cue rather than the gestures. Yes, overall, there's a the type of gesture, even though the type of gesture didn't significantly affect, there seems to be the robot effect in here. And this was part of the project, some of you might have known, big project of L-Tutor that we were part of the consortium. It was an H2020 grant, so there are many different studies, but I picked up the one that is relevant to the spatial word learning, basically. Okay, so here is the case. Spatial language and reasoning are related. Child factors as well as parental spatial language are fundamental. It can be improved, intervened. Even in second language, we can intervene, even using the robots, it seems. But we need to be careful how much the effect is specifically, in particular, in this case, robots. I want to say that in our bigger study, we find mostly marginal effects of teaching these words and stuff from the robots. That was unfortunate because we really thought that it would be the other way around. Okay. Just before conclusion, I want to say that the same links between spatial language and gesture continues even with experienced users like us, and the individual differences become even more prominent. So for example, in these mental rotation tasks, when you test adults, when people are highly spatial, they use good gestures, and the gestures they know what would help them. So this is important because even though individuals with low spatial skills use a lot of their hands, using hands correctly happens only with the individuals who have high spatial skills. And with the confidence stuff, we also showed that when you encourage adults to use gestures while solving these problems, it increases not only their accuracy, but at the same time their confidence too, their gesture. But it's important to mention that this only happens with females, not males. Even though I don't like this study, but as a start, in this case, the female-male difference. But unfortunately, as most of you know, that in these mental rotation tasks, even starting from early childhood, there seems to be a gender difference. And in this case, we found the gender difference earlier, and it looks like gesturing helps females more and increases their both accuracy and confidence more. So maybe it helps, gesturing helps or boosts those who needed them and when they need them. Okay, I think I can just conclude that there are different ways that spatial reasoning and the multimodal language can be connected, and at different time points, obviously. So our take-home messages in this case, all these interactive processes happen simultaneously or at different time points, and both environmental and technological factors can enhance both spatial reasoning and language. Since they are related, it doesn't matter in certain cases which one we focus on, because hopefully interactively they affect each other. And multimodal language is a powerful tool. So if you got interested in this, in my lab we have done so many studies about different ways that we use multimodal language. But I want to highlight that individual differences are key starting from very early on. So it's not the same for everyone, and not even the language used, not even the reasoning about space. So we have to be careful and enter individual differences into the picture all the time. So here are all my students, former students in particular, collaborators, contributed all these projects that I talked about. They do most of the job and I'm here talking about them. And this is my lab and all the funding agencies. And thank you for listening.
Thank you so much, Tilbe. Alessandra.
Perfect. I was a little bit, hopefully my talk will go okay here with this group, so when I see the questions, I get happy.
So I will try shouting. Thank you very much, very interesting. I have a curiosity about the interaction between the caregiver and the child. In the example that you were showing about the mother and child doing the puzzle, I noticed that beyond gesturing and talking, there was also a lot of contact, so active movement of the child. And I was wondering whether also this component of the interaction, the tactile and haptic interaction, could play a role there.
Yeah. Perfect, thank you. Yes, when I say multimodal, of course, as part of it, we did not code them because this was honestly, this was a very nice case, again, that I'm showing. In certain cases, we don't get it, but that's something that we have to do because it's not just particularly in younger ages. And there's research from other research groups in infancy, they show more tactile, particularly in relation to object exploration. They don't do language, so they focus on that, so maybe we should combine them. So that's a very good question. Thank you. Yeah, but I don't have it. Yeah. Yes.
Yeah, thank you so much for the talk. I was really kind of struck by maybe like some differences between this like robot teaching situation and like this puzzle case. So in the puzzle, like parent and child were both manipulating this puzzle together, like the pieces were moving.
Yes.
And in the, I guess the robot, it was sort of like repeat after me, maybe. And I guess I'm curious if this kind of like joint action or like, I don't know, kind of manipulating while in a joint action might explain some of that effect you found with the mediation between parent spatial use and child spatial use. Like they're sort of like using it together to solve a shared task.
Yes. Perfect. Yes, that's a great question. I fully agree with you. Even, I mean, in young ages, so I didn't necessarily mention it because I kind of, there's very few data points from the young children's interactive, but even in those cases, I mean, object exploration basically is that. So child brings the objects. I didn't go into detail, but that's exactly that one. So it's, again, interactive. And the more they bring the object, and we coded the child-initiated object exploration, so meaning that child takes it, brings it to the parent, and then parent says more words. Exactly, I fully agree with you. But in the other case, with the robot, yeah, probably if we make it more interactive, I mean, the child thinks that they're interacting, right? Although the child doesn't know that the robot doesn't change the speech based on the child. But yes, but I think that feeling, even in the robots, if we increase that, that will be more helpful even. I agree with you, yes. Thank you.
Okay, so first of all, thank you so much for the presentation. In the language-specific use part of your presentation, you have mentioned that the children learning the same language can follow different pathways. And what I'm curious about is, were you ever able to conduct a study with identical or fraternal twins? Because in that case, the parental factors are more of the same, but for the fraternal twins, the biology is different, the motor factor, child factors, and for identical, it's almost always the same. So were you able to conduct a study and investigating effects?
No, we didn't. Yes, that's a good difference. What we call like some different neonatal differences, right? I mean, starting from early on, but no, we didn't. But there's research in general in language development, and it looks like that even parents speak and gesture differently to their identical twins, even. So in our preterm data set, we had some twins, and when we tested them, we see that even like when you talk to parents, they say that they behave different to their children. So I would assume that the input would be different, but how they affect them and move beyond that, that I don't think there's a research on that. Yeah.
Thank you so much for your answer.
Thank you. Yes.
Hi, thank you so much for your talk. I really enjoyed it. I was curious if you've thought about cases where language is entirely gesture-based. I'm not familiar with other forms of sign language, but in American Sign Language, nouns and pronouns are used as places in space. So you'll point and then name it, and then as the story continues, you have to retain different places and remember what they represent. And so I was curious if you've looked into differences in spatial cognition and spatial attention in those cases, because babies can sign before they can speak, and they also get that spatial input much earlier.
Yeah. Perfect question. I have to say that this is all our spontaneous gestures, or we encourage people to use their hands, but this is not sign language, obviously. I don't personally do research on sign languages, and they have, with deaf children, but there is my former postdoc, Tilbe, who is currently at Middle East Technical University. She did her PhD in Max Planck psycholinguistics, so she asks these questions. And it seems that for children learning sign language, for example, which is more spatial than spoken languages, obviously, for these children, it becomes, the age of acquisition of the sign language is the key in those cases. So if they learn it late, unfortunately, they don't necessarily get the benefit of it, but if they learn it early, they are more spatially oriented and remember things better spatially, for example. Yes, there's some research, but I don't necessarily work on that. Thank you.
Thank you. So I wonder about special aspects of languages in terms of the way they're written. If you've, I know it's a kind of later stage in development than what you've talked about in this talk, but languages where you write from up to down, or languages where you write from left to right versus right to left.
Yeah. So for these relations, I wouldn't expect a difference. But there are some specific things. For example, when with adults we do like metaphors and time-space interaction and all those studies, I would expect differences in there. But here, it doesn't matter how your language encodes them. So my bigger point is, the more you know about the spatial language, the more you get the input for that is important. So it doesn't matter whether your language is right to left. I mean, in my case, it was all left to right languages. But I don't think at this age, particularly before children learning to write, it wouldn't matter. Yeah. But there are some studies arguing that with these up-down languages, it might be more beneficial, but I don't think they look into the direct links in that. Yeah, thank you.
Sorry, it's very difficult to see the order of the, please, your question.
Yeah, thank you very much. A very interesting talk, thank you. And I'm really happy that you about this notion of multimodal language. I wanted to ask a question about the fact that the people are observed to do this spontaneous movement even in absence of a communicative situation, right? Yes. So it seems that the language of space is not the language that we used to use, because even to describe this simple gesture, you would have to use a paragraph, and I'm showing you in a second, right? So maybe, yeah.
No, this is exactly my point. Thank you so much. You did it better than me. Yes, so that's why gestures are very powerful, particularly for space. I mean, the more we look into the gesture research, and I'm not the only person, obviously, the gesture research community is increasing, particularly in relation to language. But the thing is, it looks like that in spatial instances, it captures the information much better than the others. So I only talked about the production side here, but particularly with adults, we also have some studies about the comprehension. So how much you comprehend from others and gestures, and it looks like that even with ambiguous cues, gestures become more important even for other people. So we do this even unintentionally, right? We recruit the information. But I have to say one more sentence about that is there's individual differences too. The more spatial people are, for example, the higher spatial working memory they have, the more they benefit from others' gestures. That's what we also found. So it's not for everyone, but it seems that it's a powerful tool for comprehension too. So thank you. Yeah.
Thank you very much. I have to be a bad cop of the time and to cancel all the questions, but thank you for your interest, and please, we are aware that the program is very tight, but approach each other afterwards and talk to each other in the break. So thank you very much.
Yeah, totally. I'm happy to hear more questions. Thank you. Thank you.